Welcome to today's episode of Simon Says. I'm your host Simon from CRC Robotics, and today we'll be tackling on the DC motor and a way to control its speed. First of all, let's draw a motor and see how it basically works. So here's the drawing of your motor. If you put, for example, let's say 12 volts here, let's say that our motor is 12 volts, and then you put your reference or your ground, and as they say, on the other side, what should happen is actually that the motor, well, it will turn, let's say, this way, so clockwise. If, on the contrary, you do the opposite, and you put your ground over there, and you put your 12 volts over here, then it will go the other way around, or this way, counterclockwise. This is how basically you choose on which side the motor will turn. That's pretty simple. You put 12 volts and the motor turns. Not that bad. But it doesn't really help you when you try to actually control it. For example, would you really, in robotics, would you be willing to unplug the wires and come and switch them manually each time you want to reverse the motor? Not exactly. That's why, well, we're a little bit clever, and you are. And that's why we invented some ways to control it. So the first approach that was often seen in robotics during the competition was actually this one, where you use switches to actually change the voltage. So here is the drawing of your switches. And you can see that there's always one pad that is coming somewhere, and there's one pad that is open. And you put one switch on each side, like so. The side that is always open is linked to 12 volts, like so. And the side that is closed, or this one, is actually your ground. So, when you end up switching one of those, what will happen is that you'll put power on one side or the other, and you will end up effectively switching this rotation from clockwise to counterclockwise to off. Now, this is basically the principle where you will have your motor to switch side. The real problem here is that you always, what will happen is that basically the motor will be full speed always, so it's completely on or completely off, but nothing in between. Hence, that's why we created some things. It's called an H-bridge, and we'll redraw this all over. So once again, we start with our motor, like so, and we have special parts that are called transistor. They look a little bit like this when you draw them. Okay. Let me get my reference paper just to be sure that I don't write anything stupid. So yeah, as you can see, my drawing is not actually quite clear. But the idea here is that when you're using an H-bridge, there's what we call the high side, which got the 12 volts, and the low side, which got the ground, the reference. And those are actually fast acting switch compared to if you were using, for example, relays or a mechanical button. You can switch them much faster. So for example, if I'm switching this one and that one, then the motor will have 12 volts over here and the ground will be over there. It will be rotating, like I said, clockwise. On the opposite, you switch that one on and that one off, the motor will actually spin the other way around, counterclockwise, and you will have the same effect. But why do we use transistors? Well, like I said previously, One approach that could be used to control the motor speed is that, well, let's say that I don't want 12 volts and we want to reduce that to something like, if we put 8 volts, the motor would actually be slower. Actually I put 18, but I meant 8. Okay, so we put 8 volts and the motor would be going slower. That being said, the way to reduce the voltage will always cause a problem. Let's take a look at it. So, if we take one of the most basic circuits ever when you talk about electronics in general, which is the voltage divider. It goes like so. You have a voltage input, a resistor, and then your output, and then another resistor to ground. Basically, Ohm laws is stipulating that if we label this R2 and this one is R1, if we take the Ohm law of this and try to get the voltage out at this point, you can do the math if you want, but you will end up with having this formula over there, that V out is equal the voltage you put in times R2 divided by the sum of the resistor 2 plus resistor 1. And let's say that this would basically go to your motor. Okay, so this output here is going to your motor. In theory it is nice, but keep in mind one thing. Let's say that I put 1 amp over there. So there's a current of 1 amp that is going to my motor. Well, you know, in essence, that this resistor, since it's got 1 amp that is flowing through it, will generate heat based on this formula. So it will be power loss equals R times the current squared. So the more current you're drawing, the more heat you're generating over there, which is heat that you lose and power that you drain from your battery, basically eating stuff, which is not useful when you're trying to move your robot or move something else. Hence, it's not really efficient. Furthermore, if you really want, and furthermore, for the one simple reason, you want R to be small, because if R is big, what will happen is that the power loss will be increasing, so you need them small. However, and you can do the math, when you're trying to set a voltage, the smaller those resistance will be, the harder it will be to be precise. Like if you're switching from 10 to 11 ohms, and let's say that this will be 90 and this will be 10, then you switch one, it switched like a certain amount. And for example, yeah, if we take this assumption, well, it's really hard to move them. So therefore, no precision if you have low resistance. And if you put high resistance, then you have high loss and you're putting more and more and more heat, which is something that you don't want. So what do we do? Well, if you recall, a transistor can switch really fast compared to any mechanical device. So let's say that you have this. You send this to your microcontroller, to your transistor that is actually on, and you send this to both. For example, and you send this drain. So you have 12 volts over here on top, and this is simply 0 volts. This is called pulse width modulation. It's basically by sending a pulse of high and low, the average of the signal will actually be the voltage that you're sending to the motor. And one interesting fact is that the more, this region is called the on time, and that region over there is called the off time. And there's a little component which is called the duty cycle, which is basically the on time divided by the total time. So, for example, if this is like, I don't know, 50 milliseconds to take a random number. Well, if this one is 10 out of 50, it will be a duty cycle of 20%. If it was, let's say, half and half, then the duty cycle will be 50%. So the higher the duty cycle is, the more power you're transmitting to your motor, and basically the faster it will go. The advantage of doing so like that instead of using resistor is that you're basically pushing a lot of power to your motor without actually heating anything up. You're just switching on and off. And that way you can have a lot more power delivered to your motor. And usually you'll end up with systems that will have basically 98% of the energy that you produce will be given to their motor instead of having waste and anything else. I hope this helps you understand how motors are actually switched and how your microcontroller use those speed controllers in general. My name is Simon from CRC Robotics. Thank you for listening.